Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many 5-digit zip codes are possible if the digits can be repeated but the last 2 digits are even? Now for this type of situation, we are to use the fundamental counting principle in determining the number of possibilities for 5-digit zip codes together with the restriction that the last 2 should be even. Now we don't have any restrictions for the first 3 digits. So again, we have a 5-digit zip code, 1, 2, 3, 4, and then 5. This is in no particular representation for any geographic location because in the Philippines, we have a 4-digit zip code. We are just using this so that this could be applied in similar situations. So looking at 5-digit zip codes, we can try the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 for the first digit because there are no restrictions for the first digit such as 0 is not possible to be there or only odd number can be used. So that would mean there are 10 possibilities for this given placement. We are going to count all possibilities for each placement of digits, and according to the fundamental counting principle, we are just going to multiply those number of ways. So that would mean 10 times whatever will be the placement here, 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 and here as well. Now take note that the digits can be repeated. This would mean that even if we are going to use here, say for example 1 is still possible for the second digit. Hence, we are going to use here the same number of digits, still 10, because that's again possible for this. The digits here can be repeated. This is also true for the third digit. We can also use here 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? Because even if 1 or 2 of those are used in the previous digits, they can still be used here. Now, here comes the restriction for the last 2 digits. We're talking about these 2 digits here. We are told that the last 2 digits here are even. Now, there might be some discussions as to what are the even numbers, as to do we include 0 as an even number, but generally, we are going to include 0 because if any number would end with 0, that's an even number. Again, just for the discussion alone, I know that some of us might think that 0 is not included, but just for in general or most situations, let's consider 0 as an even number. In short, for this fourth digit, what we can only use here are 0, 2, 4, 6, and 8. There are 5 possibilities here. Now, going to our last digit, this should also be even. So same as this fourth placement, and since there are repetitions, so if we have used here 2 can still be used here, hence 5 digits can also be used here. Again, just for the purpose of the discussion, we included 0 as an even number just for the placement of these zip codes. Now, the fundamental counting principle allows us to simply multiply the number of possibilities for each placement. In this case, the possibilities for each digit. And the result would be 10 times 10, that's 100, times 10, that's 1000, times 5, that's 5000, and times 5, you will have here 25,000 possibilities. 0, 0, 0. Again, 10 times 10 is 100, times 10, 1000, times 5 is 5000, times 5, we have 25,000 possibilities for a 5-digit zip code where the digits can repeat but the last two digits are even, considering that 0 is also considered as an even number. So this is the result and the answer for this situation. And that's count it in. Talking about getting the luck of the draw. For all in, subscribe now.